Hi guys, I'm Aton, your future medtech. And today I'm going to show you how we prepare tissues in the histopathology section of the laboratory. But first, what is tissue processing? So the aim of tissue processing is to embed the tissue in a solid medium frame, enough to support the tissue and give it sufficient rigidity to enable a thin section to be cut, yet soft enough not to damage the knife or the tissue.
Good day, so for the first part of this video, we will be making a disposable boat that is used in the histopathology laboratory. And by the way, I am Patricia Agleron. Firstly, we are going to be needing a piece of 1/8 sized paper. Then, let's fold this paper into 3 parts in a lengthwise manner. So in here, I am just making sure that every sides or edges are finely folded. Third step is to fold the paper again into 3 parts, but now in a crosswise manner. Again, let us make sure that all the edges or sides are finely folded. So after that, let us now fold the corners of the paper. So this line and this line must meet, like this one. And just repeat the folding process onto the 3 remaining unfolded sides. And as a result of all that folding, we now have 4 flaps. Now let's fold these 2 flaps on the same side towards each other. And repeat it on the other side. Fold them towards each other. Lastly, let us fold these 2 newly created flaps to stabilize our paper boat. And finally, our paper boat or disposable boat is now ready for the embedding medium.
Hi everyone, I am Patricia Agleron, your medical technologist. So here in the histopathology laboratory, what happens first is the receiving of the sample. Thank you, sir. So when you already have the sample, it is your job to make sure that all the necessary information is filled in this container that contains the sample. Because incomplete labeling of your sample could lead to the rejection of it. So now I'm just gonna take a second look because it is really important for us to make sure that all of the basic and necessary information is here. Okay, so this is ready for documentation. After checking it, it is now ready for documentation. So now we're gonna get the logbook here in our department. So this is the logbook for histopathology. And what happens here is that we're just gonna write down all the information that comes with this. Okay, so after writing all the informations, we are not yet done because we will be needing also the name and the signature of the person who brought this specimen here in the laboratory. Hi, good morning, sir. Can you please fill this up with your name and your signature? Okay, thank you, sir. And now we are fully done with receiving. Okay, so now that we're done with documentation, we're gonna go through specimen accessioning. So in accessioning, we're gonna be needing all the relevant documents like the request form that has the patient information, patient history, and the description and the site of origin. Also, we're gonna be needing the receipt of transaction and any other pertinent documents that is completely necessary. So after going through the documents, it is now time for us to have this specimen labeled with a serial number. So this specimen comes with SP21143. So SP here means surgical pathology. So if it happens that you'll see a specimen with an AP at the first part of the serial number, it just means autopsy pathology. And we all know what autopsy means, right? So going back with the label of this specimen, which is SP21143, again SP for surgical pathology, which means that we are dealing with a live patient. And then the 21 here stands for the last two digits of the current year, 2021-21. And then the next number is 143, which is our control number. So say for example, you have received two specimens from the same patient. So to avoid confusion, you're just gonna assign a specific letter after the control number. So now that this specimen has its serial number, we're gonna document it in our logbook. So we're gonna write down the serial number, which is SP21143, the patient name, age, gender, room number, the specimen, name of the pathologist who will examine the specimen, the date the specimen is received, and of course the due date. So after writing it down, it is now time for us to fill up the surgical pathology worksheet. Okay, so after writing it all down, let us make sure that all the relevant documents are intact and is filed in one folder. Okay, and then after that, it is now time for us to proceed with fixation.
We have various ways on how to perform the processing. First is the teasing and dissociation, the squash preparation, and the smearing, which has 4 different ways: streaking, spreading, the pull-apart method, and the touch or impression smear.
But first, there are a lot of things that are unavailable in our household, but I have found substitutes for it. Like this apple as a substitute for frozen tissues, this yogurt as a substitute for bodily fluids, together with the everyday household things that would make good substitutes for this experiment.
First procedure, we have teasing and dissociation. Cut several thin slices of tissue and immerse them with a saline solution. Using a dissecting needle, carefully tease the tissue slices until they unfold and spread out. Then carefully mount a teased slice and a slide and cover it with a cover slip. For the squash preparation, add 1 to 2 drops of methylene blue stain directly in the tissue slice, and cover the stained tissue with a cover slip or another glass slide. Then, apply enough pressure to crush the tissue flat. Label your slide with your name, group number, and section. For streaking, add adequate amount of bodily fluids in the glass slide, and, using an applicator stick, streak the sediments in a straight or zigzag line. Afterwards, cover it with a cover slip. And label your slide with your name, group number, and section. For spreading, transfer a small amount of sediments on one end of a clean glass, and using an applicator stick, spread the sediments throughout the slide and cover it with a glass slide. Then, label your slide with your name, group number, and section. For the pull-apart method, place a drop of sediments on one end of a glass slide and cover it with another end of a glass slide. Allow the sediments to spread evenly between the attached surfaces of the two slides. With a single uninterrupted motion, pull the two slides apart in opposite directions and cover with a cover slip. Then, label. For the last process, we have touch or impression smear. Retrieve the block of tissue from the first procedure and cut the block in half, exposing a fresher surface. Then, allow the freshly cut surface to come in contact with the surface of a clean glass slide. Apply gently pressure, allowing the cells to be transferred directly to the slide. Cover the smear with a cover slip. Afterwards, don't forget to label. And that's it! We have performed the various ways on how we process tissues in the histopathology section.
Fixation is the first and most critical step in the histopathologic process. This is done in order for the tissue constituents to be preserved with the least alterations from the living state, with the use of the chemical agents called as fixatives. I am Aton Llevado. Now, we will demonstrate on how to perform the proper fixation of the tissue samples. So this is our tissue sample. This is a liver tissue. But first, before any fixation process to be done, tissues are examined grossly by the pathologist first, noting its color, texture, size, or any description. But for this process, the fixation, we will first get the representative sections to the tissues. We will cut a representative specimen about 2 cm squared, but not more than 4 mm in thickness, otherwise it will not fit on our tissue cassettes. So we will cut it now. So it's already cut into the preferred size. So in this demonstration, we will only have the gauze pad. So what we will do is we will wrap the tissue sample with this gauze pad. And next, we will tie it with a knot. So after this step, let's not forget to label the specimen. So in this, I have labeled it as SP-20-142. And lastly, we will now place the specimen in the glass container with our fixative agent. Observe that it should be 1:20 tissue to fixative ratio. Cover our tissues and leave for 18 to 24 hours.
Good day everyone, I am Mendoza and I am doing decalcification. So decalcification is the process of removing calcium ions from the bones or calcified tissues through histological process for it to become more flexible and easier to cut. So it is actually done after fixation and before dehydration. Now first, we will place the calcified tissue into a 500 ml beaker filled with 10% nitric acid. allow the tissue to decalcify for 12 to 24 hours. Now, after 12 to 24 hours, we will be testing the extent of decalcification. So first, we will remove 5 ml of used decalcification fluid from the beaker. Now, we will be adding ammonium hydroxide drop by drop to the solution up until the pH of the solution will become neutral. Now, since we can observe that the pH is now neutral, we can add 5 ml of saturated ammonium oxalate to the solution. Now mix it well and allow it to stand at room temperature for 30 minutes. For the interpretation of the results, if there is a formation of precipitation after adding ammonium hydroxide, then there is still presence of calcium and we should further decalcify the tissue. Also, if there is a formation of precipitation after adding ammonium oxalate, then there is still minimal amounts of calcium. However, if the solution is clear, after 30 minutes and even after adding ammonium oxalate, then the solution is calcium-free.
The next step after decalcification is dehydration. At this moment, we will perform the dehydration process.
Dehydration is the removal of water before infiltration. It is the process where the specimen is immersed in an increasing alcohol. We must always note that tissues must be immersed in an increasing concentrations of alcohol for us to prevent mechanical damage to intracellular structure of our tissue specimen. First, immerse your specimen to 70% ethanol and leave it for 15 minutes. After 15 minutes, transfer it to a higher concentration grade of ethanol, which is 90%, and leave it for 15 minutes. After that, place your sample to a higher concentration grade, which is 100%, and leave it for another 15 minutes.
With the same process, place your sample at 100% ethanol and leave it for another 15 minutes.
Next is, immerse your sample at 100% ethanol, this time for a much longer period of time, which is 30 minutes. Lastly, immerse the tissue specimen to another 100% ethanol for 45 minutes.
At this point, water molecules should have been removed from our tissue specimen. We will now place our tissue to a foil and store it.
My name is Alejandro BP De Leon and I will be demonstrating the manual clearing process. Clearing, or also known as the alcoholization, is the process of removing the dehydrating agent from the tissue sample. There is a need to do the manual clearing process so that we can proceed to infiltration and embedding, but we cannot proceed from dehydration directly to infiltration and embedding. Therefore, there is a need to do the manual clearing process in between those processes, because the dehydrating agent is not miscible with paraffin wax. However, the clearing agent, it is miscible with the dehydrating agent and the paraffin wax. And the second purpose of doing the clearing process is to remove the fats from the tissues, which would become a barrier to wax infiltration if not removed. So this is the setup for manual clearing. Here we have is our tissue sample, and we will immerse it 3 times in saline. So we will be taking our tissue sample and place it in here. And we will leave that for 20 minutes. After 20 minutes, we will be immersing it for the last time, but instead of 20 minutes, we will immerse it for 45 minutes. So after immersing it for 45 minutes in the last immersion of saline, we will put it in the paper towel to dry. After drying, we will put the tissue in the foil to set it aside for the next process.
Hi, I am Narjana S. Godoy, and I'll be tackling about the frozen section. Now, in the frozen section, tissue samples are immediately examined because there is a need for a rapid diagnosis. This is usually done during intraoperative period in which the sampled tissue are not fixed but they are frozen with dry ice. And this is crucial for the histopathology laboratory to adhere to because the surgeon needs an immediate response or the immediate diagnosis of the pathologist to act accordingly during the surgery. And without further ado, let's get into the examination. But I must first observe the proper PPE and do the experiment after. Now today we have received a specimen which is a mass from the right breast, and we will try to examine it. Now we will proceed to the grossing area because we need to first do a gross examination to the specimen. The specimen measures about 8 centimeters by 5 centimeters, but the ideal specimen size for the cryostat to operate is 3 to 4 millimeters. So we will cut it. Set aside the remaining portions of the specimen so that we can redo if we need to do it again. And then 3 to 4. Now that we have got a specimen, we should prepare a freezing medium and put it on top and proceed to the cryostat. So we will be utilizing a cryostat. A cryostat is a chamber kept at about the atmospheric temperature of -20 degrees Celsius. And the specimen that we have seen before is placed in a metal disc, and it is frozen for about -20 to -30 degrees Celsius and will be left for 2 minutes. The specimen is now embedded in a gel-like medium consisting of polyethylene glycol and polyvinyl alcohol. This compound is known by many names, and when when frozen, it has the same density from that of the frozen tissue. So after using the cryostat, we would now be performing the teasing or the dissociation process. The teasing or the dissociation process is done to carefully separate the structural parts of the tissue by the means of a dissecting needle. And we have already immersed the specimen in a saline or an isotonic solution to prevent tissue distortion. And after that, we would grab the dissecting needle and the glass slide, put it there, and then we would cover this with a cover slip.